Thank you for your patience. We will now like to start our Keynote 3. First of all, let me introduce the moderator for the session, Mr. Tanaka Nobuo. Mr. Tanaka is an ICEF steering committee, former executive director of International Energy Agency, and CEO of TANAKA Global Incorporated. So now I would like to ask Mr. Tanaka to moderate the session. Mr. Tanaka, if you please.
Thank you very much. Welcome to the Keynote Session 3. This is an enormous session, wonderful session, with 2 Nobel laureates and 2 very prominent women leading the global issues for climate change mitigation. We have Andrew Fire, geologist, and he is get the Nobel Prize for the RNA interference. He's attending us with the remote web. And then we will have Marcia McNutt of the National Academy of Science of the United States and Professor Phoebe Koundouri of the University of Cambridge. And finally, we have Sir Paul, who is also the Nobel laureate for the genetic issues. So we will start with Andrew. Are you ready for tell us about your story from wherever you are?
Yeah, I am home in California. I can tell you.
Okay, go ahead.
I'm not a climate scientist. I study biology. I study how life might have originated on Earth, and I study how new living forms, some of which are threats, can emerge in biology. I appreciate the invitation. The world is burning. How can we learn? You wake up and read the headlines online: fires, smoke, storms, wars, disease, and climate change. We can study any of these. We can learn about any of these. We can't prevent them, but if we learn a bit, we can try and make a difference. There will still be fires, smoke, storms, wars, and disease, and there always have been. Is a sustainable world where there is no change? There's no such world. We live with a changing, challenging world with many problems. We will live with a changing, challenging world, and it will still have many problems. So is science fruitless? Science is not fruitless. We need science. We need science to live with all the change. We have needed transportation technology since humans migrated from one place to another. We have needed public health since humans contracted the first communicable disease. We have needed agricultural biotechnology since the first blight. We have needed housing, heating, and cooling since we do our best. It's never perfect, but humanity has continued. 3.5 years ago, our greatest challenge was a disease, COVID. 100 years ago, our greatest challenge was a disease, flu. And in between, we have dealt with the ravages of AIDS, polio, and more. There will be other challenges with diseases and health. The new public health challenges will be emergencies, and we will need to deal with them. But 3.5 years ago, we didn't stop research in energy sustainability and climate. We needed to continue it. So even during the fire of COVID, we continued research in climate and energy. And as we address COVID, we are back to the reality of the existential threat that climate change is. We need to do research. We need to continue. We will never solve the problems of the environment. They will always be there. We will need to continue investigating, measuring, predicting, and innovating, particularly innovating. Because humanity will continue to face challenges of our own making and from the natural environment, we will need to continue doing science even if we have solved all the problems we currently face. We will never solve the problems of public health. There will always be disease. There will always be infectious agents, some new and some old. There will always be environmental challenges to health. And humanity will challenge our environment in every way until a danger is reached. We will keep doing things until we get into trouble. There will always be wars. There will always be disasters. Sustainability of humanity requires sustainability of our science, our research, and our technology and development. It is part of being human. Even during the fires, we need to research floods. Even during the fires, we need to research and study infectious disease. Even during the fires, we need to be aware of the needs for international peace. And our needs in each area are driven by change. So change in environment generates new environmental challenges, but also new public health challenges, and sadly, new international security challenges and wars. So as odd as it seems, even in the midst of a fire or a pandemic or environmental disaster, sustainability that requires that we continue doing what we've been doing. Science directed towards the immediate problem, science directed towards other problems that may not be so immediate, and science directed towards fundamental knowledge that may be a long time before we realize the benefits. Thus, we need to provide sustainability in our scientific enterprise for now and the future. And as important as every individual problem is at any given time, expertise is the most important. In one area, if we have expertise, we can provide it to people doing research on other questions. By collaborating, by communicating, by working with each other in different fields, we can solve some of the most important problems. Finally, a bit of a message to some of the younger scientists and future leaders here. We will bequeath the world to you with many problems, my generation. We were bequeathed the world with many problems from the previous generation. The problems now are different, but the need for science is ongoing. After my apology that the world we bequeath has more problems than the world we inherited, we should say, you will face challenges. There will be difficulties in all areas. We were called upon to innovate, advocate, compromise, listen, and lead. Nobody called us and told that. We just had to figure it out. Nothing was simple. Nothing went as expected. You will be called upon to innovate, advocate, compromise, listen, and lead. Nobody will call upon you and tell you to do this. It will just be your duty. I can guarantee nothing will be simple and nothing will go as expected. Yet in some year, you will be bequeathing a world to a new generation, a world that you have done your best to improve. To a generation, you will be bequeathing this world that you have done your best to educate, enable, and facilitate. And I know that you will do this with the same apprehension that we and previous generations have felt for the future of humanity, as every generation has done. But you also will do so with the hope that we have. The greatest optimism that I have comes from the energy that the current generation is putting into the fight against climate change and for a sustainable world. This is very encouraging, and I hope you will have a similar encouragement from the generations you bequeath to. There is nothing that humanity cannot do if we work together. Thank you.
Thank you, Andrew. Very encouraging, though a little optimistic, but I share your view for this optimism. Yes, we have to solve the problem of climate change with international collaboration and whole, I would say, everybody should move based on the facts or evidence built by the science. But my question to you, Andrew, is that, yes, I cannot agree more with what you have said, but how the scientists can convince the politicians, sometimes who are not really believing or try not to believe science, rather going to the constituency and being elected. How? Because policymakers, the politician should understand the scientific reality and truth to make correct policy. But is it difficult, or
Yeah.
you are more optimistic about it?
Oh, you went silent here. Hello?
Yes, go ahead.
Yeah. I don't have the answer to that. I wish I did. I mean, there ought to be a science of how people work in communities and groups. I don't think there necessarily is, but there ought to be a science of that. And we have to understand that politicians really, at the end of the day, are reflecting what the people think and do. And if we can educate people to make decisions when they vote that are decisions for the future, that would be a benefit. I don't know how to do that. I think somebody needs to solve that problem, and it will be a really major contribution when they do.
Thank you very much. Let's try to be optimistic to convince politicians. Let's move to Marcia. Marcia McNutt is the head of the National Academy of Science, and she will give us about the sustainability and some kind of trade-off between the SDG issues. Go ahead.
Wonderful. Well, thank you all very much for having me here today. I have a simple message that I want to convey to you all, and that is, as we pursue our goal of limiting climate change on the planet, let's make sure that we thoroughly investigate our solutions so that we don't have unintended consequences that affect other parts of our sustainability challenge. So we can all remember or cite numerous cases where solutions to one of the sustainability goals also advances others. The most obvious one is applying affordable and clean energy. When we do that with solar panels and wind power, we also are addressing climate action. So that's a case of a solution that benefits both of those sustainability goals. Or, for example, when we use technologies to provide clean water and sanitation, we also advance global health and well-being by limiting the incidence of things like cholera, dysentery, typhoid, polio, etc. And another example is providing quality education to all citizens advances decent work and economic growth and reduces inequalities. There's a clear trend globally that the more educated your population is, the more your economic growth is going to be, and you also reduce inequalities. But too often, our approaches to the sustainability goals are in conflict with each other, and we have to find solutions that don't do that. So, for example, when we address zero hunger by clear-cutting the Amazon, or by over-fertilizing with chemical fertilizers, we create dead zones in the ocean, we reduce the amount of wild space for biodiversity, and we also negatively, in fact, impact climate action because we reduce carbon sinks. What I'd like to argue today is with sufficient innovation, and of course innovation is the first word of today's meeting, we can create win-win scenarios where we can advance some goals without detracting from others. So here's a good example. Another approach to zero hunger, rather than taking up more wild space for growing crops, is to engineer crops to be, first of all, more resistant to climate change, to be more resistant to pests without using pesticides, and without having to increase the amount of land under cultivation. So this is a win-win scenario. Another example that I'd like to mention is a development that sort of came out of left field. That was the development of the internet. The rise of the internet advanced the U.S. economy by 22% per year since 2016, at a time when other industries, legacy industries, were growing at 2 to 3% per year. It's also given rise to all sorts of other benefits, such as we saw during the pandemic. We could actually consult with each other without having to travel. So we were addressing climate action by doing virtual meetings. And it also is advancing other things such as telemedicine, improving the health of those who are unable to access medical care. It's providing e-learning platforms to advance education, and there are a number of other advances that have come from that. But I would say more research is needed to anticipate negative repercussions of solutions to the sustainability goals before they are actually manifest and before it's too late to turn us back from those solutions. So some of you here are probably old enough to remember a time, it was more than a decade ago, when there was a proposal that we could solve the climate change problem by disposing of CO2 in the deep sea. And there were a number, this is just one of the cartoons, but there were maps that actually showed where there were power plants around the coastlines and how we could put pipes out into the deep sea, collect the CO2 from power plants, distribute it down in the deep sea where it would be out of sight, out of mind, and that would be our address to climate, our solution to climate change. However, at that time, I was the director of a small research institution in California called the Monterey Bay Aquarium Research Institute. And let's see if this video will play. Yes, it is. So two of my scientists at the Institute noted that no one knew what the phase diagram was of CO2 at deep ocean pressures and temperatures. The idea that had floated around was if you put CO2 in the deep sea, it would pond and create in deep places, and there would be a CO2 ice that would form on the top of it, thus stably sequestering the CO2 in the deep sea. But because there was no phase diagram, no one knew if that was really the case. So two of my researchers, Peter Brewer, who is a chemist, and Jim Berry, who is a benthic biologist, decided, well, let's figure out what CO2 actually does in the deep sea. So we took a remotely operated vehicle and put actually a beaker, a glass beaker from the lab, on the bottom of the seafloor at 4 kilometers depth and injected CO2 into that beaker. What you can see in this diagram, what happened was a runaway violent reaction where the CO2 interacted with the seawater and increased in volume 20-fold once it was in the ocean. And the ice, rather than forming at the top of it like ice does on a freezing lake, the ice formed at the bottom of the beaker, expelled the CO2, and it went bounding down the continental margin in a runaway effect. So this research was published the next month in Science magazine. Within hours, every single diagram like this that had been on the internet was taken down, and this was never talked about again. So this is a case of a scientific experiment actually showing the fallacy of something that was widely thought to be a great solution and stopping it in its tracks. So let me go on to say that we've got other issues like this that are on the horizon. For example, in order to maintain industrial innovation in infrastructure, there is a huge demand for critical minerals. And everyone knows that there are these manganese nodules on the seafloor and buried under the sediments that are very rich in these critical minerals. And there are lots of proposals right now to mine the deep sea for these elements. But yet, again, it's one of these out-of-sight, out-of-mind problems. We know the damage that mining on the land has done to ecosystems, to water tables, et cetera. We need to investigate this issue long before it gets to industrial scale. Here's another one that is right on the horizon. We heard Steve Chu this morning talk about the issue of clean water and how desalination is one proposal. And again, we see all these diagrams of intaking water from the ocean, desalinating it, and then putting out the brine into the ocean. Again, the brine is out of sight, out of mind, but no one has actually investigated what this brine at industrial quantities would do to life in the ocean. And you probably can imagine, I'm a marine scientist, and that's why so many of my examples have to do with the negative impacts of, on the oceans from these new technologies. And let me just end with this. What about AI? AI is poised to become the most disruptive technology since the internet. And there are many advantages for human health, economic growth, more judicious use of resources, climate prediction, lots of hope that we'll get much better climate models with AI and other applications. But what about the energy usage? I talked to a friend of mine who's an engineer at Microsoft. He said they built a big warehouse out in the Nevada desert in order to house the big servers that are used for these large language models. These servers use an immense amount of energy. And so they did a study on how many solar panels would it take to power this large AI server farm just with solar energy. The answer was they would have to pave over the entire county in Nevada where this facility was in order to get enough energy. So I think we need to be thinking about all of these implications of AI, including for energy usage as we go into the future. So let me just leave you with this quotation. It's easy to dodge our responsibilities, but we can't dodge the consequences of dodging our responsibilities. Thank you very much.
Thank you, Marcia. It's a very wonderful story. We cannot dodge the effect of dodging the responsibility. We have to be responsible for our decision now. By the way, you mentioned about very interesting, let's say CO2 dumping or putting deep sea as an ice. So this kind of engineering solution for the climate change is somewhat very interesting, though the impact to the environment is very much sometimes considered as questionable or negative. So we haven't discussed much. The issue is so-called geoengineering. And geoengineering may be a kind of ultimate solution for the global warming, but the impact, can we recover the original position? You know, that kind of risk is preventing us going into that direction. But I understand that the National Academy of Science certainly discussed in survey about geoengineering. Do you think it's a very important element for the future of climate change mitigation? And should ICEF discuss about that? Yeah.
Yes, so there are basically two approaches to geoengineering. One approach is the various carbon capture technologies. Those are generally thought to be more expensive than just mitigating to begin with. And they're slow to take effect. The ones that are really immediate are the ones where we put particles in the stratosphere, sulfur particles, in order to reflect sunlight, in order to cool the Earth. These are much cheaper, and they have a much quicker response. But we don't actually know what the unintended consequences might be. I think it's generally the opinion of the experts at the National Academy that we would be foolish not to understand more about these, the full implications of doing it, because what we're worried about is that with the slow pace of action on climate change, we could find ourselves back against the wall People are dying. Civilization is collapsing. And we don't know the answer to the question, is geoengineering worse than the disease we already have? Is the cure worse than the disease? And that's why we say we really need to do the science right now so that we can answer that question definitively.
Thank you very much, Marcia. That's right. Yeah, if we take that decision, certainly we cannot dodge the let's say, impact of our decision. So the science is definitely needed to understand the consequences. Thank you. Let's move to Phoebe-san. I think you have lots of experience about modeling and the issues in Europe, etc. And what kind of say suggestions or recommendations you have to us?
Can I have my presentation? Thank you very much. So thank you very much for having me here. I will try to convey the work that we do for presenting at national level decarbonization pathways for the transition to climate neutrality. So first of all, we all know the multi-crisis that we are in. We have the COVID, we have slow economic growth, inflationary pressures, very thin fiscal space in many countries, not just developing countries, climate change, biodiversity collapse, and all of these are leading to huge inequalities. And the good news is that we have, as Maria said before, our blueprint, the 17 Sustainable Development Goals, 169 targets within them, and we need to figure out how to implement them. I lead an Alliance of Excellence for Research and Innovation on IFORIA, putting together the work of 5 different research institutions and a number of accelerators with hundreds of startups, technological, financial and social innovation startups, and also working with big networks like the SDSN, the United Nations Sustainable Development Solutions Network, the European Association of Environmental Resource Economists, and the World Council of Environmental Resource Economists. I myself am a mathematical economist and statistician, but this group is very interdisciplinary. It is interdisciplinary because the only way to identify the solution pathways is to have a really holistic approach, and this is what I'm going to talk today about. And of course, all we do with regards to our modeling, it's always integrated in the existing policies for sustainability, the SDGs, the Global Climate Agreement, and then the transposition of all those in the different continents. For example, we had before the European ambassador, he elaborated on how the European Green Deal transposes the SDGs into implementable policies, the Fit for 55, the EU taxonomy. All these are very good. We have efforts in Europe. We have efforts significant in China and India. So all I'm going to talk to you about today, which is mostly focused on science-driven modeling, it's within this framework. It's about implementing this existing policy framework. Now, first we start with how well are we performing against the SDGs. Every year, UNSDSN produces this report that tells you how each and every country in the world is performing against each SDG and each target against the SDG. We are seriously underperforming. The blue line shows the projection if we keep the pace of performance, and the green line shows what we need to do in order to get full implementation of the SDGs by 2050, which we are not going to get, but it's good to have the right target. I co-authored the report for Europe. The more you downscale, the more detail you can integrate in your measurements, and we need the measurements, because in order to achieve a goal, you need to agree where you are, So this measures where you are in terms of performance, and then you need to develop the pathways in a science-based approach to reach where you want to go. So this is the first step, and it is important, and you can see only Scandinavia is performing well enough. And of course, you can downscale even further at country level. This is Greece, for example, and you can downscale even further. This is regions within Greece. Why is this important? Because in order to implement the SDGs, and if I bring it back to climate change, dealing with mitigation and adaptation, it is important to have the local level considered. It is the detail, the devil is in the details. Okay, this is the situation. So let's imagine a world where we all agree that this performance is correctly quantified. What do we do next? Well, next we have to devise the pathway towards the target. We agreed the targets, 169 targets within the 17 SDGs, 163 countries, 193 countries have signed. So we have the target, we know where we are, we need to get the pathways clear. And this is what the Global Climate Hub of SDSN is doing, and I'm happy that I am leading it with 200 researchers across Europe and beyond working on the pathways. And basically what we do is we provide national governments detailed, optimal mixture of technologies, policies, financial instruments, and socioeconomic narratives for the implementation of the targets. And these are dynamic mixtures of technologies, policies, and financial instruments, very detailed, so that they can be implemented by governments. Because if you go nowadays, the last say 4 to 5 years and talk to governments, nobody will tell you I don't care about climate change. The effects are here, they know that they should care. What they tell you is that I have a national climate and energy plan, and it's so difficult to downscale. So this is about downscaling and providing the needed detail for implementation. Our Climate Hub has 9 different units, and this is what I think is needed for a holistic, integrated, and implementable approach for the transition to climate neutrality and climate resilience. And I'm gonna go very quickly across the different units. The first is about the data. You need to collect, aggregate, connect, and visualize the data, and you need the geospatial data, and you need the socioeconomic data. We've been gathering the data. The projects that you see that are going through this, the slider are projects supporting those collection of the data, and we are building an operational AI-driven data infrastructure to combine the data, to extract the information, and to create indicators, a community of indicators and people that validate this data in order to do what with the data. And it is important to have all this data, and it is very useful that nowadays we have satellite data and in situ data and sensor data, which is really very helpful for allowing us to run our models to present pathways to the nations. The second unit is about atmospheric physics and climatology, and this is mostly the work of IPCC, but we have a unit that tries to downscale this work at national level and identify influences of human influence on a wide range of climate variables. Then is the climate and energy systems modeling. Here we use Balmorra model. It's a very integrated intersector holistic systems that models energy supply, energy demand, climate policy, and simulates scenarios that can provide detailed values for all the relevant variables along the resulting temperature increase. So at the end of the day, you have decarbonization pathways suggested through this integrated system at European level, regional level, and national national level. And you can even figure out the basic result of our European report, which we will present along with the report on the Balkans and the report in the UK. We will present this in COP28 in Dubai. Our general model, which is also downscaled at national level, showcases that Northern Europe, of course, has large potential for offshore wind, district heating, onshore wind, biomass availability, Central and South Europe, cheap solar, hydrogen industry, and we can also figure out an energy source and hydrogen infrastructure spatial distribution that can give you a good pathway towards 2050. And then it is important not to forget the other huge system that you have to integrate in your pathways. And this is the land use system. And here we use the work of Fable Consortium. This is led by IASA and SDSN. My team is working on the green pathways. We have more than 20 countries in this Fable Consortium. And actually this focuses on agriculture as the main driver of land use change and allows you to test the impact of different policies and changes in the drivers of this system. So at the end of the day, you can create scenarios that allows you to showcase how shifting diets, increasing crop and livestock productivity, and also limiting agricultural land expansion can allow you to achieve food security, your climate targets, and your biodiversity targets, and then integrate these scenarios and pathways with the energy scenarios. And this is the pathway for Greece, for example, that allows you to have a land use system that is climate neutral by 2045. The next unit is about climate and health, identifying and monetizing the physical and mental the effects on physical and mental health from climate change and integrating this in your policies and cost-benefit analysis of alternative policies and investment. Next unit is innovation acceleration, which is very relevant to this conference. Innovation, not just technological, but also social innovation, and of course, innovation, financial innovation, financial instruments. At the moment, we incubate under 3 accelerators, hundreds of startups, and of course we are not the only ones, startups that are dealing with mitigation and adaptation on both the energy system and the land use system. Very quickly, after you do all of this and you have the pathways, you need to talk to the governments and the politicians and the policymakers and the businesses and the financial institutions about how you're going to finance the implementation of the pathways, and how you're going to protect those that will be negatively affected by the transition. Because there are some sections, economic sectors, and sections of the economy, groups, income groups within countries that are going to be negatively affected. And you have to find a way to mitigate these regressive effects. I will give you a snapshot of important elements of this transition. First important message is that the European Green Deal for us Europeans is very good. It's a leadership transposition of sustainability into policy, but it's not as holistic as the SDGs. So if you do an AI exercise, you will find that the European Green Deal is very good in sustainable food, land, water, and oceans support and sustainable energy decarbonization, but is lacking behind on the social elements, on the social cohesion. It does not really invest money on social cohesion. It does not invest a lot of money on education, on job market reforms and all that. So we need to be aware of that and identify our responsibility in order to create social cohesion while we strive for this unprecedented transformation that we want to achieve in a very limited amount of time. Other socioeconomic message is that we need to integrate natural capital in our decisions, and I'm going to finish very fast. In order to do that, you need to monetize natural capital. We environmental economists have been working for the last 70 years on monetizing ecosystem services, and these need to be included. In an exercise that we did around the globe, these are European results, we have identified the willingness to pay for different ecosystem services, and we show strong correlation between the countries with high willingness to pay and the countries with good performance in their respective SDGs, climate action, a life below water, land use. And of course, you need to create the fiscal space for those countries that do not have the fiscal space. And you cannot create that fiscal space if you don't tackle the high cost of debt and rising risk of the distress. So basically, you need to create long-term loans for countries of financial distress with low interest rates. The SDGs are long-term targets. They cannot be achieved in 4 and 5 years, and the loan cannot have a high interest rate if it's gonna really work for the countries. So we have to, and this is something that we are working as the Pontifical Academy of Social Science, Jeff Sachs is leading this. We really need to scale up affordable long-term financing for development through multilateral development banks and aligning this with financing flows with the ESGs. And with regards, not just the global south, but also within the developed world, as I told you before, there are many vulnerable. We have done a general equilibrium analysis of how you can implement the climate policies of Europe and at the same time care for the vulnerable, and it is doable. If you devise clever packages of measures, lump sum transfers, targeted energy efficiency measures, job retraining programs, funding of subsidies that promote carbon efficient technologies, you can actually implement climate policies, achieve higher growth, achieve increase in jobs, and at the same time reduce inequality in all European regions. Finally, it's very important to get the private sector on board, the business sector on board. What we did is that we developed a methodology that allows mapping the environmental, social, and governance criteria, the so-called ESGs, into the SDGs goal. Why we think this is useful? Because the ESGs do not talk about profit, do not talk about the profit of the company. Whereas if you transpose the SDG framework to a company framework, then you can showcase how a company can achieve environmental, social, and governance objectives and at the same time increase profit. And this is what the companies are asking. The business of business is to do business and have profit. So can we showcase along the value chain of a business how transformation and new technologies and new policies can achieve better environmental, social, and governance impact, and at the same time increase profits? And we have, this methodology allows you to show how each company performs against each SDG, what is the gap between where it is and where it needs to go, and then identify the transformation along the value chain of the company in order to achieve it. And we have done a small experiment with stocks around the world using 11,400 stocks just to see whether it pays companies to be SDG hedging against SDG risk, and this is the factor mimicking portfolio of value of $1 invested in SDG specific portfolios. And you can see how they increase over time, and you can see how they compare with other portfolio. This is the blue line, which goes up and performs better than any other portfolio. is the portfolio that hedges against the SDGs. Finally, you cannot do that only by science and policy making. You need all the stakeholders. So I refer to politicians, policymakers, businesses, financial institutions, science, and of course, technologies. And you need to work with them in a way that engages them and allows them to feel ownership of the pathways and allows them to become shareholders of the pathways. And finally, in order to do this, the best way is education, upskilling, and reskilling to create the capacity among the stakeholders to really participate. I want to close by saying that we really need the socioeconomic narrative of this very holistic approach in order to convince the governments to implement. So IPCC report gives us the cost of inaction, but we also want to showcase who is going to pay the action, for the action, and how we are going to protect for the vulnerable if action is really taken. Thank you.
Thank you, Phoebe-san. Very, very good presentation about the whole of this modeling and the pathway implications and how to explain. I mean, I don't know if politicians understand the whole of the modeling you explained to us. By the way, just one small question to you is that I asked the same question to the astronaut Noguchi-san. In your modeling, do you put certain, let's say, consideration to the so-called planetary boundaries? I mean, the tipping points, etc. Are you put these elements into your modeling?
Yes, they are very crucial. All these variables that we are working with and their relationships are highly nonlinear and have tipping points, very dangerous tipping points. And usually you don't only face uncertainty, you also face ambiguity. You don't know the probabilities of the possible events. So this is one big element of our work, an element of our work that is not really easy to convey to policymakers. To policymakers, it's enough to show them a concept note and the resulting effects, and then convince them about the socioeconomic narrative, that you can support those that are gonna face regressive effects.
Thank you. And I cannot agree more that financial innovation or fiscal innovation is necessary in the policy arena. And we haven't, I mean, in ICEF, we haven't discussed much about it, but in the future, probably we have to take it up. Let's move to Sir Paul.
それでは
Not last but not least, please tell us about your story.
Thank you, Tanaka-san, and thank you for the invitation to speak on the panel. To be quite honest, I'm a bit of a fraud here. I'm no climate change expert. As you've heard, I'm a geneticist and cell biologist. But I was president of the Royal Society, the UK Academy of Science, 10 years ago, and did have to comment on a range of global issues with major science aspects, including climate change. And I thought about that and tried to put together some common features which I'd like to discuss with you. So I hope there's something interesting there. I'm going to talk about 4 topics. The first is the problems that arise when discussing scientific issues which have a high social impact. And these problems arise because ideological and political arguments are never far away, and they become entangled with that science. In the case of climate change, there are people who do not like what society will have to do to counter global warming. And they therefore try to undermine the science. Sometimes this is deliberate. Sometimes I suspect they're just very confused about what science is and what opinion is. Such people see the communal activity required to deal with global warming runs counter to their freedoms as individuals, because the initiatives that are necessary restrict behaviors of countries, companies, and of individuals. And as a consequence, they challenge the validity of the science. It's one of their tools in their armory, contaminating that science as a consequence with ideology and with politics. And that makes it more difficult to what I call slay the dragon of mistruth that is climate change denialism. That dragon is difficult to slay because it constantly changes shape. It morphs. It never seems to die. It starts with the assertion there is no global warming. When that becomes untenable, it morphs to it's not caused by humans. And when that becomes untenable, it morphs to we don't have to do anything just yet as other issues are more pressing. I'm waiting for the next morph. Don't quite know what it might be. This confusion of ideology with science is made worse by organizations claiming to be scientific that promote these mistruths. Sometimes they recruit scientists, even quite good scientists in other areas, and use them to cast doubts about the climate science. And I saw this a lot when I was at the Royal Society. A scientist working in another area, working perhaps with in an area like high-energy physics where scientists operate in precision to many decimal places and probabilities of 4 to 6 sigmas, they may well feel uncomfortable, as they see it, with the less precise climate science. But such scientists need to be careful when straying from their own experience, from their own capabilities. Care and perhaps humility are both required. Second point, global crises have had wide effects. They touch many different intellectual disciplines. So this topic is to emphasize the need for multidisciplinarity. The natural sciences, the range of natural sciences, the social sciences, the humanities. Lots of things need to be thought about. For example, in addition to the obvious global warming, human health, increased temperatures leading to heat-related disease, effects on infectious disease, such as increases potentially of zoonotic transfers of disease vectors from animals to humans, agriculture, food production, food security, all that we've been talking about. How we can generate heat and drought-tolerant crops, how we may need to reduce meat consumption because of its effects on CO2 levels. Also mentioned biodiversity loss. As warming is happening so fast, living organisms and ecosystems simply do not have the time to adapt, putting biodiversity at risk. It's a little like the dinosaurs and the asteroid. Happens too fast for adaptation. Then let's turn to people and their behaviors, which requires, of course, the social sciences, the humanities. How can behaviors be changed? How is trust earned to keep the public on side? How can complex science be explained? How can circular economies put in place? In addition to all of this, actually, all these different disciplines need then to work together. And that's not so easy either. It requires practice. It requires talking to those that have different languages, have different ways of thinking, have different cultures, apart from coming from different countries, different religions. So this requires effort, and it needs to be put together. It is being put together, but it's critical. My third topic, one we've also briefly touched upon, engagement with people. That is the general public and our political leaders. Both, of course, need to have trust in the science. But given that science can be quite complex, it can often be difficult to put in place. And always remember, trust is earned in teaspoons and lost in buckets. Very easy to lose it. A key factor in trust is seeing scientists as people. It requires scientists that can engage with the media and can engage with other people who are not scientists. Not all of us scientists can actually do that. They need to be calm, measured, humble again, all combined with being passionate and persuasive, as we learnt this morning. This needs very special people like my friend David Attenborough, who in the UK is so exceptional at doing this. It's not easy, but if somebody can do it well, we really need to nurture them. We really need to encourage them. A particular problem I find is, how do you handle skepticism? Being skeptical is really good in doing scientific research. You have to challenge yourself, challenge other people. You have to be your own worst enemy of your own favorite hypothesis and idea. But such skepticism is good, in other words, for good science, but such skepticism does not play nearly so well in the media. It leads to doubt, and it allows the opposition, which will not have doubt, to really dominate the narrative. Scientists mustn't be seen as remote, but as part of humanity and working for the good of humanity. They also need to emphasize the long-term matters. It's not all short-term, and a focus on thinking about the future for our children and our grandchildren and our great-grandchildren, I think obviously helps here. Let's turn specifically, briefly, just to our political leaders, because there is another problem that we've also already mentioned. Firstly, though, our interactions, I believe, with our politicians should as much as possible be non-political. So all political parties of all colours will listen to the science. But the major problem, I think, is the short-term electoral cycle of 3 to 5 years, which means issues of climate change fade away because they're always so far, 2050, even 2030. Our politicians need to learn that having a long-term vision, dealing with these issues, is a positive political virtue. And so quickly is it lost as an election comes up. We have to talk to the public and politicians in different countries, and it differs because of the different cultures. No one-size glove fits all, but we can all learn from each other as to what might work. Finally, and briefly, I wanted to comment on the organizational ways of working that are required to deal with these sorts of crises. I think we need to have in place absolutely clear objectives that can be closely adhered to. Volatility is not helpful. You have to have clear objectives. You need to think about them so they don't wither away, they don't change. Secondly, we need firm accountabilities at all stages of the processes that we need to put in place. They're complex, and we need to know who is responsible for the particular actions and who is therefore necessary to making those things work. Too often the accountabilities get diffuse, and that leads to inaction. Thirdly, to deal with these crises, we need to identify all the experts. Remember, it's multidisciplinary. We need to make sure they can work together, and we need to make sure they are available. And those that happen to be good at communication need to be trained, and they need to be used. We also have to ensure that the public and private sectors are working closely together. In addition to that, the research and development sector are working closely with manufacturing. All of this is obvious, but actually does take work to make sure that it's worked. All are needed. And then the last thing I will say, we need to accept we will fail on occasions. We will fail. So we need to develop resilience. That is the ability not to simply give up, but to actually recover from failure, to find a way out of failure, to make sure we have resilient processes and people in place. And that will be needed because we are in this for the long haul, and it's a long and complex problem. Thank you very much.
Thank you, Sir Paul. It's a great statement about this we will fail and resilience is necessary. What we had experienced here in Japan in the Fukushima accident of the nuclear power plant. It's a huge failure. Are we showing the resilience of coming back? This is a very interesting question. The science or scientists should be responsible to some extent to show the public that science is trustworthy. And to make it happen, I think scientists should play a very, very important role together, not individual and different messages, but clear common message about the nuclear power by the scientists is probably still necessary for us to convince the public to regain the trust to this very, very important technology. By the way, my question to all of the panelists is about the artificial intelligence and its use for the climate change mitigation, or also to the genetics. I think for the sake of genetical researches, AI may be very important for the future. Do you agree with, I mean, what are the limitations for that? Or, and certainly for the climate change modeling, I think, Fabe-san, we may need the use of AI substantially. Go ahead with Paul.
Phoebe, do you want to say it because of the modeling, then I'll follow up with it.
For us, it's crucial for managing big data, crucial, because the data requirements of these models are extensive. And then with regards to modeling, is also very, very useful, especially when you realize that in order to manage these systems, there is a demand and supply side. We talk a lot about innovation and technology on the demand side, but there is a lot that is going on the supply side. Sorry, technology is about the supply side. But there is a lot to do on the demand side to change behaviors. So you start from the micro level, meso level, macro level. So AI is crucial in order to identify relationships and in order to integrate different scales, and in order to integrate visuals and quantification. So it is extensively used, but I would say it is still in a primitive stage. The models need to be updated with better, more advanced AI technologies, and there is a lot of research on that at the moment.
Thank you. Sir Paul.
Yes, so AI, obviously very interesting. I talk a lot with Demis Hassabis, who is the man who established Google DeepMind. He's adjacent to my institute, and he's got labs in our institute, the wet labs. And where I think we have to think more, we have to think beyond what I say artificial intelligence is doing at the moment, because it allows you to identify connections, but it isn't so good at identifying understanding of the processes that underpin it. And we need to think about how we can combine those two different sorts of thinking, because obviously those correlations and understanding them are really important. But we need to sort of, if I could just, reduce this to ridiculous simplicity, I mean, we need to combine machine learning with differential equations, if you see what I mean. Yeah. That is to say, we have to use machine learning to actually direct us in thinking about understanding. Now, obviously you can predict weather without understanding any, I mean, we're already showing that. But it will be good in this long haul here that we're doing through climate change to actually have some understanding what's going on underneath in addition, because otherwise there is a potential for error and maybe significant error.
Understanding of causality, which allows you to change behavior, yes. Anything that is endogenous needs understanding.
Exactly.
Andrew, do you have a view about this use of AI?
I guess I don't really know the answer to that. I see a lot of tools that don't involve AI that can make a tremendous difference. And I see a few cases where, like the internet, like a calculator, like a computer, it may make a difference in the way that we apply human intelligence to solve problems. But in the end, we'll be applying human intelligence to solve problems, and it will, I think, need to be that. So I think it is one more tool in the quiver. It's also one more thing that will certainly be misused, like the internet, and will be a way to increase misinformation in some cases. I hope there'll be ways to regulate that.
Thank you. Marcia, I think you mentioned about AI consumes lots of electricity. So to need the location of the data center is probably a very important issue for the future. What do you have the view about the use of AI and its limitation or kind of prerogatives to make it happen?
Well, I'd say the first thing that we need to do is understand how AI does what it does. AI, most of what we see in like ChatGPT is just natural language processing. And so why that should be able to actually show inference is beyond me. So, I ask these AI engineers, why does it do that? They don't understand. I think we need to understand it.
Thank you very much. I'd love to continue this discussion forever, but maybe time is up already. So thank you, the panelists, for a really wonderful discussion about from the science and from the more, the important element of researches in the modeling and in the climate change mitigation. I think ICEF should have a lot to do in the future, and this homework is really heavy for us. But I'm really delighted. I really wish all the audience to join me thanking the panelists. Thank you very much.